You're watching A-League
Math. Samuel Kim Production.
Alright, so here we are. It's chapter 4 now that we're going to start today. Section 4.1 is what we're going to be taking a look at. And this part starts our whole conversation on trigonometry. I don't know if you remember trig from grade 10, grade 11, but we're going to do more of that kind of stuff. Today we're going to show you how we can look at angles and angle measures in a different way, one that you've never seen before, and that's why it might be a little bit weird, but I hope to explain this well to you so that you can understand this quite easily. Okay? I'm going to actually start you off by looking and asking you to think back to grade 10 and how in grade 10 we learned how to measure things using two different systems. Remember what those systems were called? Yeah, they were the metric system, or the SI, the System International. An example of that would be something like centimeters. And then there was also the imperial system, what they use in the States or in Britain. And the example from there would be something like inches. So remember how we were measuring like lengths, and we can use centimeters and inches? If you're not too sure, just look at your ruler, right? A lot of times your ruler has both. Well, we're going to do the same thing now with angles. So in elementary school, you've learned that a full circle is made up of 360 degrees. So we use degrees to measure angles. And so it was understood that 1 degree was really just 1/360th of a full circle. Well, now what I'd like you to do is look at the following picture on the left. Okay, this one over here. Here is a circle with a central angle, that's the central angle here, subtended by an arc equal in length to what? Well, the arc equal in length here to r, which is called the radius of the circle. So what I'm saying is if you have a central angle that has an arc length of r that's equal to its radius, we've got this crazy central angle, and we have a special name for it, or a special measure. So this central angle measures actually 1 radian. Yes, you might have seen this on your calculator. It's the RAD thing that you see, or the R. And so this is our new unit of measure for angles. Just like how we had centimeters and inches for measuring lengths, now we have radians and degrees. Okay? Now, we need to find a relationship between these two, just like how we have a relationship between centimeters and inches. And so to do that, let me follow along here. Well, it says, what's the circumference of a circle with radius r? Hopefully you remember this. Circumference c is equal to 2 pi r. Okay? So what I'm saying to you here is, so if the arc length r is equal to 1 radian, then the arc length of 2r must be equal to how many radians? Now to do this, perhaps setting a proportion might help. So I'm going to set a proportion right here. I'm going to compare the length r with the 1 radian. Okay, so I'm comparing length with angle. And if I'm doing a proportion, I'm going to set up another fraction. I'm going to compare that with the entire length, or the circumference. And that's in reference to what angle? And if you think about proportions, I'm asking r times what gives you 2 pi r. And I hope you know that it's 2 pi. So therefore I should take 1 and multiply by 2 pi to give me what's the question mark. And of course the question mark should be equal to just 2 pi. So what I'm saying to you is that the arc length 2 pi r must equal 2 pi radians. Therefore, and here's the big thing. one full rotation, or 360 degrees, is equal to 2 pi radians. This is the conversion factor, although we don't usually refer this as the conversion factor. We try to find something else, and I'll show you in a second when we do this exercise underneath. Alright, so let's keep going. I want you now to complete this table, please. Okay, one rotation, 360 degrees. That's 2 pi radians. Half, of course, so half of 360 would be 180. Half of 2 pi would be then just pi. So a lot of times textbooks use this and say 180 degrees equals to pi radians. So keep that in mind. Okay, I'm going to box this. We can go further and say, how about 1/4? Well, 1/4 seems to be 90 degrees, right? 1/4 of 360. And so 1/4 of 2 pi is just pi over 2. An eighth would be 45 degrees, and then it would be pi over 4. And ultimately, if I asked you for 1 degree, that would be 1/360th of a rotation. So over here, this would be 1/360th of 2 pi, and that simplifies just to pi over 180. So some textbooks will say this: 1 degree equals to pi over 180 radians. Okay, either the thing in blue or this in purple is the conversion factor that I want you to know. Okay. So what we're going to do first is just convert 60 degrees to radian measures. I'm going to try to show you how to convert degrees to radians, and of course I'll go vice versa. I'm going to show you actually 2 ways to do this. Use whichever one you like. I have a preference to what I like, but once again, it's up to you because you're the one that's learning. If I were to use something called unit analysis, what I want you to note here then is we're going to use that idea that 180 degrees equals to pi radians. So what kind of unit measures can we create, or what kind of unit factors? Well, therefore, we actually have 2 unit factors. We can either use this factor, which is 180 degrees over pi. Once again, this is equal to 1 because these 2 things are equivalent. Or we can use pi over 180 degrees. Once again, they're equivalent, so when I divide each other, it equals to 1. Right? I'll say both equal 1. So, if I want to now take 60 degrees, which unit factor do you think I should use? Should I use 180 over pi or pi over 180? Well, remember, the idea here is to get rid of the degrees, so I want to have the degrees in the denominator, because once again, the degrees disappear, and I'm left with, of course, radians. Well, 60 over 180 can be simplified to just 1/3. So this is just pi over 3 radians. And that's your answer. Okay? Now, if I want you to try the same thing with proportional reasoning, once again, proportional reasoning is a fraction. So I guess the fraction I can use, any of the unit factors will be fine. I'll just use pi over 180 while I'm comparing radians on the top to degrees on the bottom. And so I'm saying I want 60 degrees. And so the question is, what goes on top? I guess this is x. So what I can do now is you can solve either by doing the division, or some people like to cross multiply. So I will show you how to cross multiply. Of course, cross multiply means you take these and multiply them together. So I get 60 pi on one side, and then I get 180x on the other. I want you to solve for x, so 60 pi over 180, and of course that's the same thing as pi over 3. Same answer. Okay? Alright, turn the page, and I'm going to ask you to go the other way now. So I'm going to ask you to convert 2 pi over 3 to degrees. Show you 2 ways. And by the way, if no units are written after the angle measure, always now assume that we are talking about radians. Okay, you're in grade 12. Those of you doing calculus, always assume that it's radians. All right, by unit analysis, I'm going to go 2 pi over 3. And once again, you have the choice. Your choice is either 180 over pi or pi over 180. In this case, I want degrees, so I want to keep degrees on the top. So I'm going to multiply by this factor, 180 over pi. You can simplify here. 3 and the 180 simplify to 1 and 60. The pi's and the pi's just divide out, so I think I'm just left with 120 degrees, and that would be the correct answer. Doing it by proportional reasoning, once again, it's a fraction, so I'll just write down pi over 180. Once again, radians on the top, degrees on the bottom. And in this case, I have my radian measure, which is 2 pi over 3. I don't have my degree measure, I'll call that x. We'll once again cross multiply. So pi times x equals to 180 times 2/3 pi. 180 times 2 pi over 3. Now, of course, that simplifies, so once again, that's 160. That's just 120 pi. So pi x equals to 120 pi. Divide both sides by pi. I get 120 degrees. Pretty straightforward? Good. That's not it, for this section at least. What I'd like to do next is actually review something you should have learned in pre-calculus 11. Some of you, I know, should I say most of you, probably forgot this, so that's why I'm reviewing it for you. Okay. Then I'm going to introduce these terms like the angle and standard position again and ask you to sketch them. But this time I'm going to combine not just degrees, which is what you did in grade 11, but now radians, what you're doing in grade 12. Okay, here we go. So just to review how to draw angles in standard position, the idea is you can draw angles on a coordinate system. And to do so, we use two rays. Okay, rays are just lines with an arrow on one end with a common endpoint to show the angle. Okay, now to do so, I'm going to ask you to please begin your ray at the positive side of the x-axis. So we always begin here. Okay, that's where your first ray is. Then rotate your ray counterclockwise. So that's once again counterclockwise, going upwards like this, to draw a positive angle. And of course, if I want to do a negative angle, of course, you just go the opposite way. That would be clockwise. Now, the positive side of the x-axis has a name to it. It's called the initial arm. While the ray that rotates around the origin also has a special name. It's called the terminal arm. Okay, I won't ask you these terms in a test, but you'll see them and hear them quite often, so it's good to know them. Well, here's our definition for an angle in standard position. It's the angle that's between the initial arm and the terminal arm and the vertex is at the origin, and this angle we give a name called theta. Okay, so the variable for angles is theta, not x but theta. Well, here's what I'd like us to do in example number 3. I want you to just practice sketching these angles for me, please. Oh, I guess before I do that, maybe we should do a quick review, okay? And we can compare degrees and radians. Degrees, of course, here this would be 0 degrees, and as we move 10, 20, 30, 40, 50, 60, 70, 80, a right angle here would be 90. And then we have obtuse angles, 100, 10, 20, 30, 40, all the way over here to be 180. We can continue further. We get reflex angles all the way to 270. And we rotate back around, we get 360. Okay, one complete rotation. Well, what happens with radians? Well, we still start with 0. Okay, 0 radians though. as we rotate to 90, what is the equivalent form in radians? Well, you can either figure it out by multiplying by pi over 180, or you can look at that chart we did on the page 1. It's up to you, but the answer here is pi over 2. So this is pi over 2. 90 degrees is equivalent to pi over 2. So what is 180 degrees equivalent to? Well, that's just twice of pi over 2, or pi. Remember how we said 180 degrees equals to pi? That's something that's pretty key. Well, here it is again. Well, as I keep moving on, I guess I'm going to add another pi over 2. So this is just pi plus pi over 2. Think about what that would be. If I were to do the common denominator, that would be actually 3 pi over 2. So over here, this is 3 pi over 2 radians. That's the equivalency of 270 degrees. And then if I went full circle, what do you think it would be? If you said 2 pi, you are correct. Okay? So hopefully you can get this in your head. This is very important. You're going to have to know these. Make sure you remember pi over 2 is 90, pi is 180, 3 pi over 2, and of course 0 and 2 pi for the beginning and the end of a complete rotation. Alright, now let's go on to example number 3. I'd like you to sketch the following angles in standard position. And by the way, if you can do these without listening to me, by all means do that first. Okay, so always pause the video, try it, and then come back. If you get it, hey, that means you understand it. That's great. If not, that's okay. You're learning. Go back and review. Okay, so remember all of them start on the initial arm, and because this is negative, I'm going backwards or clockwise. This is negative 90. This is probably negative 180. So probably somewhere here. So I'm assuming that this would be negative 225 degrees. Okay? We're going to try this one, next one, 3 pi over 4. Once again, we're starting at the initial arm. And now I'm going to rotate, so 3 pi over 4. Remember, this is pi over 2, so is 3 pi over 4 bigger than pi over 2? Well, this is where your fraction knowledge comes into play. And the equivalent fraction is 2 pi over 4, so yeah, I think 3 pi over 4 is bigger. It probably is somewhere here. Okay? 3 pi over 4. And last but not least, we have 495 degrees. So once again, we'll start on the initial arm at the positive side of the x-axis. We will rotate probably at least one complete rotation, because that's 360. And then if I keep going and adding another 90, what's 360 plus 90? That's 450, so I have to go a bit more, but 45 degrees more. And I'm thinking, here we go. This is our angle of 495. Well, what do you notice about all these angles? Seems like the terminal arm of all 3 angles are in the same spot, or I'll say position. And these angles have a special name if they're all in the same spot. Their terminal arms are all in the same place, so we don't call them terminal, but we call them coterminal. So C-O, terminal. So let me give you a quick definition of coterminal angles, and I'll give you some more practice with them. So, coterminal angles are angles in standard position with the same terminal arm. And they may be measured in degrees or radians and always differ by 360 degrees or 2 pi radians. I don't think this is really new for you because I think you did this in grade 11. The only new part now is dealing with radians. Okay? So for each of these cases, example number 4, I'm going to ask you to please sketch it out and then determine one positive and one negative angle measure that is coterminal with it. So 315, I will sketch this out, starting once again on the positive side of the axis here. I'm going to now rotate around 90, 180, 270, 315, stop. There's 315 degrees. Okay? I'm asking for one positive and one negative angle measure. Well, guess what I have to do there? So another one would be just adding 360 to it. So how about 675? That would be just going around one more rotation. If I wanted a negative angle, well, I could just take, instead of adding 360, I'll subtract 360. That seems to be negative 45 degrees, and that's cool. Okay. Try the next one here. We got negative 5 pi over 6. I'm starting at the positive side of the x-axis again. This time I'm going backwards, so this will be negative pi over 2. And then this over here would be negative pi. So if I were to do negative 5 pi over 6, that's a little bit less than 1 pi. So probably right here in the third quadrant. And we have here negative 5 pi over 6. Once again, I'm going to ask you to find one positive, one negative. So for the positive one, I'm going to add not 360, but 2 pi. And by the way, to do that, you need to find the common denominator. So the common denominator seems to be 6. How do you convert 2 pi over 1 into something over 6? Yes, you do multiply by 6. So negative 5 pi plus 12 pi is 7 pi over 6. Okay. Similarly, if I want another negative, I will instead subtract 2 pi. And of course, that's the same thing as negative 5 pi over 6 minus 12 pi over 6. Negative 5 take away 12. How about negative 17 pi over 6? Ta-da! Okay. And before I do part C, why don't you try part C? It's very similar to part A. Let's see if you can sketch this one out. This one seems to be more than pi, so I'm thinking probably third quadrant. I'll let you figure out how to find these other angles. It's the same as before. This time, of course, we want the denominator of 4, so I'll use 4. And I think the other one, pretty self-explanatory. Same idea. 5 pi over 4 minus 8 pi over 4. 5 take away 8 equals to negative 3 pi over 4. Okay. Hope you're feeling good about this. I don't think this is too hard. Yeah, there's a little bit of fraction stuff, but if you know how to do fractions, you should be okay. Alright, let's go back to the notes. It says here, it looks like that any given angle has, and the key word here is I can keep going on and on and on, adding 360 or subtracting 360, or in the radians case, adding 2 pi or negative 2 pi. So there seems to be an infinite number of angles that are coterminal with it. Since each time you make one full rotation, you arrive back at the same terminal arm. So my question to you is there a way to describe all the possible coterminal angles? Well, let's take a look on the next page. It says for each angle in standard position, identify all angles coterminal with it that satisfy the domain of either negative 720 between, or sorry, angle between negative 720 and 720, or if it's in radians between negative 4 pi and positive 4 pi. Okay, well, that's pretty straightforward. Just like before, we just have to keep adding and subtracting 360 or 2 pi. Easy. 300 plus 360. How about 660? Should I add another 360 more? Probably not, because I want to stop at 720. So let me just go backwards now and subtract 300. 300 minus 360. Well, that's negative 60. Should I keep going? I think I should, because I can do a few more. Minus 360. That's negative 420. Should I try another one? I guess I could. Negative 420 minus 360. That's 780. Oops, that's way too much. That's past my boundary. Let's not worry about that. So there are my answers. Okay. Try the next one here. Okay. Where I'm going to ask you now for theta equals to pi over 3. So do the same thing. Pi over 3 What do I add in this case? Yes, 2 pi. And that's the same thing in this case as 6 pi. So that's 7 pi over 3. You're thinking, where should I stop? Well, remember, this is 4 pi's I'm asking you. So maybe you can do the equivalence. Instead of having this as a denominator of 1, if I had a denominator of 3, what would it be? Well, 4 times 3 I think is 12. So that's me saying, hey, we have to go up to 12 pi over 3. So should I stop at 7? Probably, because if I did one more, watch what would happen. 7 pi over 3 plus another 2 pi, which is 6 pi over 3. That's 13 pi over 3. I'm over, so don't go there. I guess all I need to do now is just take pi over 3 and subtract. 2 pi, pi over 3 minus 6 pi over 3. Well, that's just negative 5 pi over 3. That's good. We'll do one more, I think. Negative 5 pi over 3 minus another 6 pi over 3. That's negative 11 pi over 3. Once again, we're taking negative 5 pi minus 6 pi. We get negative 11 pi over 3. Done. Okay. You can try the next one. I'll do this quietly on my own. You do yours on your own. I think this one we should keep going. 3 pi over 4 plus another 8 pi over 4. That's 11 pi over 4. I think we can stop here. I will then ask you to go and subtract 2 pi. And I think I can stop here because once again, if I were to change the restrictions on my domain and make it a denominator of 4, I think it's negative 16 pi all the way to 16 pi over 4, of course. Okay, so 1, 2, 3. Alright, I'm going to extend this now. Example number 6, and we'll end with this. See if you can find a way to describe all possible coterminal angles over this domain using an expression. Well, ladies and gentlemen, what did I do from above when I did 300 degrees and I had to find all these coterminal angles? If you said I just added or subtracted 360, you are correct. How many of these can I do? Well, I can do it once, I can do it twice, 3 times, 4 times, 5 times, 6 times, 7 times. I can do it an infinite number of times. So we can write our answer like this. It's 300 degrees plus 360 degrees times n, where n stands for the number of rotations. So n, I guess, could be any integer, because it could be 1, 2, 3, or negative 1, negative 2, negative 3, and so on and so forth. Some people will write it like this instead. They'll say 300 degrees plus or minus 360 degrees times n, but in this case n must be a whole number because you don't want to have minuses again. Just seems redundant. Okay, but you need to put either the integer part or the whole number part because we can't have decimal or fractional portions of a rotation. They have to be whole numbers. Okay, so over here, this one would be pi over 3 plus, in this case, not 360 but 2 pi because it's radians, n, where n is an integer, or once again pi over 3 plus or minus 2 pi n, where n is a whole number. Once again, I prefer actually the one on top, but if you like the one at the bottom, that's up to you. And last but not least, same idea, just add 2 pi n's. Okay, pretty straightforward, I hope. Cool, because I think we're done. Oh, except for one last thing. What's all this stuff called? It says, the above ways of showing all possible coterminal angles is called the general form. We're going to use this stuff again later on, so please make sure you know it. Bye for now.